Understanding cycle detection in graphs.
Cycle detection is a fundamental problem in computer science. A cycle occurs when there's a path in a graph that starts and ends at the same node. Detecting cycles is important for applications like dependency checking, deadlock detection, and analyzing networks. Let's explore simple techniques and see some sample code to find cycles in both directed and undirected graphs.
Detecting cycles in undirected graphs.
For undirected graphs, a common method to detect cycles is using depth-first search, or DFS. If you encounter a visited node that isn't your immediate parent, there's a cycle. This is a straightforward approach that works well for most use cases. Next, let's look at an easy-to-understand code example using DFS.
Sample code, undirected graph cycle detection.
Python code example. Def has cycle, graph, node, visited, parent. Visited node is true. For neighbor in graph node, if not visited neighbor, is has cycle graph, neighbor, visited, node. Return true if neighbor is not parent. Return true, false.
Detecting cycles in directed graphs.
Cycle detection in directed graphs is slightly different. The most common method uses DFS, keeping track of nodes currently in the recursion stack. If you revisit a node that's still in the current path, a cycle exists. Now, let's see a code snippet that demonstrates this approach.
Sample code, directed graph cycle detection.
Python code example. 5 Python code, def has cycle, graph, node, visited when neighbor. This name string, if it not visited. Name string, if, has cycle, graph, node, visited when neighbor. Return, true.
Summary, choosing the right method.
Detecting cycles varies by graph type. Use DFS with parent checking for undirected graphs, and DFS with a recursion stack for directed graphs. These methods are efficient and practical, and the code can easily be adapted to fit most programming tasks. With these basics, you're ready to handle cycle detection confidently in your own projects.